going through the review sheet today and Monday. We're going through half of it today, half of it Monday. Tuesday, Wednesday. Tuesday, Wednesday. Finishing the review. You're good? So, all right, guys, let's look at the first four problems. So the first problem, fourth root of 20,736. So, all right, guys, focus in. Fourth root of 20,736. Now we could do this here. So we can say the fourth root of 20,736 is 12. Now, since we took an even root, we have to put the plus or minus, because it could be positive or negative, especially when we're applying this nth root. Because when we apply the nth root or doing these problems here, we're saying what times itself 4 times is 20,736. Now, 12 to the fourth power is indeed 20,736. Negative 12 to the fourth power is still 20,736. It gives us the same value. So that number could be positive or negative. So it's plus or minus 12. Now, if we do the same thing with number 2, the ninth root of 512. Let's try rewriting that again. 512. Let's see what we get. Ninth root of 512 is 2. So when it's telling us 2 to the ninth power is 512. Now what's negative 2 to the ninth power? Negative 512. If it was an even power, an even root, it would have turned that negative back positive. But with an odd root, if it starts positive, it's going to stay positive. If it starts negative, it's going to stay negative. So that's why we only have one real number for odd roots and 2 real numbers for even roots. And we take that even power. Questions on 1 or 2, or 1 through 4? Just 3 and 4. 3 and 4 are the same thing. Questions on any of this here? Yeah, because if it's odd, we only have one root. We add the plus or minus only on even roots. If it's an odd root, if we're taking the odd root, n is odd, we only have 1. So 3 would have the plus or minus, and 4 would not. Because if we look at the 14th root of 16,384, 14th root of 16,384, we get 2. Because 2 to the 14th is our number, and negative 2 to the 14th gives us the same thing. So the 14th root of 16,384 would be plus or minus 2. Because if our root, our index is even, we have the plus or minus. If that index is odd, we only have the positive or negative case, and it will tell us what it is. Because if we take the odd root and get a negative number, it's a negative. If we take the odd root and get a positive number, it's positive. It'll tell us exactly what it is. Evaluate. Problems 5 through 8. When it says evaluate, we're wanting a number, we're wanting a decimal, we can plug them in. So 8 to the negative 2/3. 8 to the negative 2/3 is 1/4. Questions on number 8 or 5? 8 to the negative 2/3. Questions on number 6? So what would we type in for number 6? That would be, so 1, 2, 3 parentheses, then 1/4, close parentheses, to the negative 5 halves, then to the third. Yep. Well, it's just saying we can't type anything else after that. It's run out of space. But I know that 1/4 to the negative 5 halves to the third is 32,768. Because again, when we apply powers, if we always work from the inside out. So we start from the middle and go out. Another way we could have done this is started with the first one, which is 1/4, and we said it was to the negative 5 halves is 32. Now I hit the exponent key, so it says A and S. A and S is the previous answer. Well, our previous answer was 1/4 to the negative 5 halves, so our 32. And the next exponent we would put it to is 32,768, which we already got, to the 6/5 is still 262,144. Get to the same answer. $144. Questions on 7 or 8? Or do we feel good about 7 and 8? Okay. Questions on anything so far? For problems 9 through 12, evaluate each expression and round to the 4th decimal place if necessary. On the test, it will say if necessary. Because if we approximate or calculate one of these and get 7, do we need to round to the 4th decimal place? No, there's no decimal place to round to. But if we look at the first one here, 6, second x root, make sure that 6 goes up into the index, because it will give you a different answer otherwise. 9, 7, 4, 2, 3, 1. 9.9565813. 4 decimal places would be 9.9566. If you're not sure on that 4th decimal place, give me the whole decimal place. That's fine. But again, we need at least 4 decimal places because it asks for 4. I need at least 4. Don't give me 9.9. Ask for 4. I need 4. Any other questions on 10, 11, or 12? We feel good with these here. Evaluate. Evaluate means we're getting a decimal number. We can plug it in because we're evaluating it for that expression. (13 through 16). Well, the first one is 6 to the third to the 1/4. Yes? I will definitely mark it wrong if you put 3.833658625. And the big reason it asks to simplify, it didn't ask to evaluate. Powers of powers do what? So 6 to the third to the 1/4 are 3 to the 1/4. 3 and 1/4 would multiply to give us what? We simplified it. Because it's not asking for the value. It's not asking for us to evaluate it. It just wants us to simplify the expression as far as possible. That's it. Now, if you do want to make sure you got it right, I mean, we could grab the calculator and say 6 to the 3/4. Are those the same number? Okay, so I got the same answer. That answer is correct. Some of them will simplify nicely. Some of them won't. Because here this doesn't, so we have to leave it at 6 to the 3/4. Let's look at 14. There are different ways to approach these here. There's different ways to answer these. Because we could go about it doing powers of powers, multiplying and simplifying from there. The other option is there a common factor or something that reduces with 48 and 27? Well, we can just 48 over 27 is 16 over 9. So that does simplify. Now, one of our properties of rational exponents, it's our quotient of a power of a quotient. It says if we have two things being divided to a power, we can apply that power to both terms. We can go the other direction. If we have the same power being applied to the top and bottom, we can pull it back out. Because as we just saw, 48 over 27 can reduce to 16 over 9. Now, there is something else that's nice. We already did it once on 13 powers. The powers do what? Multiply, yes? What's negative 1/2 times 4? It is negative 2. All right. So where we're at is 16 over 9 to the negative 2. Now, there is something nice, something interesting, and I don't know if we've talked about it too much. I know I've talked to a few of y'all about this. A over B to a negative exponent. What we could do is apply it to both, but we can't leave it negative. We've got to flip it. The B's exponent, to make it positive, it has to go to the top. If the A's exponent, to make it positive, it has to go to the bottom, yes? Or we can just say that when we have a negative exponent, we're going to have to what? Flip it, yes? 16 over 9 to the negative 2 would therefore mean that it's the same as 9 over 16 squared, because we can apply it and flip it. Is 9 squared or 16 squared a nice number? 9 squared, 9 times 9 is? Because 9 squared is 81. 16 squared is 256. Because 9 squared simplified nicely, 16 squared simplifies nicely. So we'll simplify it. We can't simplify 6 to the 3/4 because it does not simplify. The number on bottom is saying that we need to find a number times itself 4 times. And even if we cube the number on top, it's still not going to give us something that simplifies. Questions on 14? $15. Looks worse than 14. Yes? If we look at this here, we have 2 to the 2/3 times 16 to the 2/3, all over 4 to the 2/3. Now, we did this with the last one because if we had the same exponent on top and bottom, we can pull it out. Yes? We can do that with division. We can do it with multiplication. We can't do it with addition or subtraction. But is there addition or subtraction on top or bottom? No. So what we could actually say is that this is the same as 2 times 16 over 4 to the 2/3. We can pull that exponent out of the two terms on top, term on bottom. Which leaves us what left inside? 2 times 16 divided by 4. Yes? What's 16 divided by 4? Times 2. So we're left with 8 to the 2/3. Now the 2/3, the 3 on bottom says that we're taking the cubed root. We're trying to find a number times itself. 3 times it, that is 8. 2. And then we would square it to give us
4.
Yeah. Not all of them will simplify nicely, but some do. This one did. Gives us 8. Now the question is, what's the next one? Is that the fourth root of 8 times, that's coming up, isn't it? 4 to the 1/2 times 3 to the negative 1/2, or negative 3/2. 4 to the 1/2, negative 3/2 to the 1/4. All right, let's look at this here. Inside the parentheses, we have like bases being multiplied. When we multiply like bases, we can add the exponents. So really inside this here, we're looking at 4 to the 1/2 plus negative 3/2. And 1/2 plus negative 3/2 is indeed negative 1. And we could do that in a calculator. We can ask it to do 1/2 plus negative 3/2. Powers of powers, negative 1 times negative 1/4 is, that's why I didn't simplify, because there is not a fourth root of 4. There's not a number multiplied by itself 4 times, that gives us 4. 4 to the 1/4. Really, we could say 2 to the 1/2. I will take either, because 4 is 2 squared. 2 over 4 reduces to 1/2. But that's it. Questions on this here? We ready for the next one? Don't need that page. Problem 17 through 20, we want to simplify. Questions on one of these in particular? 19. The cubed root of 6 times the cubed root of 72 all over the cubed root of 2. Now, there's different ways we can get to this, because it's all depending how we want to work the problem. Yes, because one of the things we could do is take the cubed root of the entire thing. And the reason I would do that is if any of the terms on top will simplify completely or fully with the term on bottom. That's going to make this nicer. Well, 672, either one of those is divisible by 2, yes? Well, what's 72 divided by 2? So 6 times 72 divided by 2 is the same as 6 times 36. Now we're looking for a number times itself how many times? 3, yes? Now we can break this all the way down, or if we have a number times itself 3 times, it would simplify, yes? We wouldn't need to, it's 1. Because really we could say 6 times 72 divided by 2. Because we could divide the 6 or the 72. We can't divide both. Yeah. Because 6 divided by 2 would be 3 times 72. Because 6 times 72 is this, divided by 2 would be 216, which is 6 times 36, or 3 times 72. Does that make sense? Yeah, we pick one or the other. We can't do both. Yes. So, we look at this here. We're looking for a number times itself 3 times, yes? What's 36? 6 times 6, yes? What else do we also have up there? So we could say this is the same as what? The cubed root of 6 cubed, which is, because again, it's not really specifying a specific number. We just need to figure out what times itself 3 times is that number. Well, 6 times 6 is 36. We already had a 6, so we have 3. Now 72, the other way to do this is take our prime factorization, our factor tree. Yeah, it gets to the same thing. Yeah. Because here, 72 is 2 to the third times 3 squared, which is 3 times 2 to the third times 3 squared. 2 cubed. Well, 3 times 3 squared is also 3 cubed, yes? Cubed root of 2 cubed is 2. Cubed root of 3 cubed is, what's 2 times 3? There's different ways to get there, because it's really just rearranging, working it so we have those cubes, and just so we get those even roots. Because again, if it simplifies nicely, any calculator will simplify it because it is simplifying nicely. Now, 18, yes. Because if you want to start there, you can. If it simplifies nicely, it simplifies. Now, if we look at number 20, we already saw that. I typed it in earlier. 4th root of 8 times 4th root of 8 gave us a decimal, yes? Now, 8, we're going to do 2 steps at once. One, we're multiplying like radicals are both 4th roots. We can write it as a single one with what's inside being multiplied, yes? 8 is what? 2 to the third, yes? Because 2 times itself 3 times is 8. So we're doing 2 steps in one. Because we're rewriting 8 as 2 to the third and multiplying them together. Yes. Because when we multiply like bases, we add the exponents. Now, if it was, say, 2 to the 8th, that would simplify nicely. Because, again, with our roots of 4, we need 4 groups of 2 to come out. 8, we'd have 2. How many groups of 4 2s can we take out of 2 to the 6th? 1, because we can take 1 4 out of 2, yes? So outside this 4th root, we would have 1 2. How many 2's do we have left inside? 2. So this simplifies 2 4th roots of 4. Because 6, 2 times itself, 6 times inside the radical, yes? 2 to the 4th power would simplify to 2. But we still have 2 left over. 2 squared is back to 4. Or, I mean, it is the same as 2 square roots of 2. 2 to the 4th. It's how it works. But I will take this here. Because 4 root, because we're taking out groups of 4 from that 6th power. So each group of 4 I can take out, we pull 1 out. I can do once, 4 minus 6 minus 4 is 2. 2 stay inside, 1 comes out for each group of 4. Get ready for the next one. Questions on 21 through 24. Which one do you want to look at? 23, square root of 7 over the square root of 10 minus square root of 2. Now, doing this by hand, we would multiply by the complex denominator. Then we'd multiply through the top, which would be square root of 70 plus the square root of 14. And we multiply on bottom, we would have 10 minus the square root of 20, or that'd be plus square root of 20 minus square root of 20 minus 4, which is square root of 70 plus the square root of 14 over 6, and then we could yeah.
actually real piece.
Yeah, because again, the 30xs likes square roots. It'll simplify in radical form. Square roots. It'll simplify square roots in radical form. It doesn't do cube roots, fourth roots, sixth roots, eighth roots, anything above it, only if it simplifies nicely. If it does, it will simplify it. If not, it gives you a decimal. These have radicals. Yeah, there'll be a few of those there. Just plug it in. Any of them. 1 over 1 plus square root of 3. 1 over 1 plus. Yeah.
I'm plugging it in.
There won't be one specifically like 25 on the test. I'm not going to give you one where you have to simplify 24 to the 1/3. It does simplify. It's actually 8 times 3 to the 1. Yes, 2 to the 1/3. All right. Let's look at 26. 26, for us to be able to simplify this or add or subtract, those radicals have to be the same. They're both cubed roots, but I know that for us to be able to subtract, they both have to be the cubed root of 2. Now, 128 is 2 times 64. Now the question is, can we take the cubed root of 64?
Yeah.
4.
I think that's the
So actually, the cubed root of 128 is 4 cubed roots of 2. Five cubed roots of 2 minus 4 cubed roots of 2. 5 minus 4. So we have 1 cubed root of 2. Because again, once we get the radicals to be the same, we subtract their coefficients. So we subtract the numbers in front of them. So 5 minus 4 is 1, telling us that we have 1 cubed root of, the 2? Oh, the cubed root? So we started out with cubed roots. Now, cubed root of 2 is as simplified as it gets. So since that's as simplified as it gets, the only way we can add or subtract is if they both had a cubed root of 2. So 128, 2 is a factor of it, 2 times 64. Cubed root of 64 is 4, so we pull it out, and we can subtract. Essentially, we're using the numbers given to get there. Now, there might be one on the test where there's multiple, and we have to simplify down all the way across without any hints given. Square root of 150. So 150, if they're going to be able to add or subtract, we know that both of them have to be the square root of 6. So if there's a square root, a number times itself, that multiplies by 6 to give us 150, that would be nice. Well, 150 divided by 6 is, can we take the square root of 25? 5. So we're just trying to break it down, get it simplified as possible. Yeah. Because we're really not so much looking at just 25, we're looking at the square root of this number. Square root of 6 doesn't reduce. But the square root of 25 is 5. So it goes out front. But we also had 7 times 5. One more time. If we couldn't, if it was, say, 35 instead of 25, that's as far as it goes. It would just be simplified. We couldn't reduce it, so there's no way to add it. Yeah. Now, the reason we can do this square root of 6 is because it's going to reduce. because also kind of it's a little bit of a cheat, the fact that they're going to have to reduce. I'm not going to give you one that's just simplified. So they have to both have a square root of 6. That's why we use the 6. Does that make sense? Yes. 27 plus 35. Because again, the 30xs likes radicals, those square roots. 30xs likes square roots. So 28, because they're both square roots, the calculator will do it just fine. Cubed roots and above, it'll only do it if it simplifies nicely. So if it's a cubed root and doesn't simplify nicely, so like 26, we would have had to have done that one by hand because we're left with the cubed roots of 2. The calculator won't just do the cubed root of 2. Let's look at 29 and 30. When we divide like bases, we subtract the exponents. So we have n to the 18th over n to the second. 18 is the same as 18 minus 2, n to the 18 minus 2. We have p to the 7th over p to the negative 1, which is the same as p to the 7 minus 1. Yeah, I realized I flipped the numbers. I went back and fixed it on y'all's paper. I just didn't fix it on my notes. 18 minus 2. 16. 7 minus negative 1. 8. Negative and negative make a. So we're left with this here. Now both exponents are positive, so we can move on and simplifying this. How many groups of 8 can we take out of 16? 2. So it's going to reduce to n. How many groups of 8 can we take out of 8? Now the technically the correct answer would be n squared absolute value of p, because we need that value of p to be positive. We can't take an odd even root and get a negative. But our variables could be positive, negative, or 0. So the fact that p is to the first power, if p was negative, without those absolute value bars, it would come out being a negative value. Put those negative absolute values bars in to offset it. Now the question is, why don't we put them around the n? Well, n is to the second. Anything to an even power, if it's negative, it becomes positive. If it's positive, it stays positive, yes? Yeah. If it's an odd power, we'd put it. I'm not going to make y'all put them. I'll take n squared times p. Yeah, it's one of those technicalities. Because of the square, it offsets that negative. We don't need them. Since p is to an odd power, we need them. Let's look at 30. Now again, like most of these here, there's different ways we can do this. One of them, when we divide like bases, we subtract the exponents. So g, we have g to the 6 on top. How many g's do we have on bottom? None, so it's just g to the 6. Next one, we have h to the first on top and h to the 7th on bottom. Gives us h to the 1 minus 7. 1 minus 7 is what? Negative 6. Now, before we simplify this radical, we'll need to make that exponent positive. It's going to make it easier to work with if it's positive. Well, to make it positive, we just got to put it back on the bottom of the fraction. Okay. How many groups of 6 can we take out of g to the 6? 1. So we're just left with g on top. How many groups of 6 can we take out of h to the 6? G over h. Now we could have put an in-between step and say that we have the 6 root of g to the 6 over the 6 root of h to the 6, which is still just g over h. We get the same thing. Even root, starting out with, so we would put absolute values around the whole thing, make sure it stays positive, but again, I would take g over h. Questions on this here? Any questions on any of this so far? We're good? Solving is the next thing. Now we're going to do this on Monday. I'm going to go on and write the steps. Yes.
Go to the office, see about this before.
Yes. Two. Put both sides to the nth power. 3. Are there any radicals left? If so, repeat steps 1 and 2. Then our last step is to solve. But again, we'll do